Well, we've spent a lot of time learning about how rockets work. I thought I'd like to end this week's lectures with a more personal account of what it's like actually strapping yourself on top of 4.5 million pounds of high explosive propellant and then taking off and riding the rocket up into space, something I've been fortunate enough to have done 5 times on the space shuttle. And I'd like to share some of my impressions with you of what it's like flying into space. It's kind of nice the night before launch, they light up the launch pad, and this is a very emotional time for the crew. Of course, we've been training for 1 year, 2 years for a mission, but now you're down at the launch site. It's where the rubber hits the road, so to speak, and this is the real thing, and you have this sense that all your preparation is sort of now coming to a peak. So it's really exciting going out that night before the launch and watching the beautiful spacecraft all lit up. There's kind of a tradition at NASA, at least. We all get up in the morning and have a breakfast. Back in the old days, it was a kind of when men were men, so to speak. People would have steak and eggs for breakfast. One of the things that affects a large percentage of people who go up into space is space sickness. And once we became a little more aware of that, the breakfast tended to reduce. I typically would have just a piece of lightly buttered toast and a cup of tea. I never had trouble with space sickness, but you don't want to push it. Also, they always bake us a cake with our mission emblem on it, which you can see down here. Nobody ever eats that cake. We never really figured out what happens to them. But in any case, it's a nice time for the crew to get together, take a few last photographs. Then you go into the suiting room, and this is pretty standard for all rockets. We want to wear pressure suits
donning their flight suits
so that on the way up, if the rocket should spring a leak and lose pressure, we can still retain consciousness and hopefully get back for a safe emergency landing. There's a pressure suit inside this orange suit that I'm in. The orange material on the outside is fire retardant and also gives a certain amount of protection against any hazardous chemicals, of which there are a lot around the launch pad. So we get into our suit. They test to make sure the pressurization holds if we need it, which hopefully we won't, and I never have. Then, with a lot of to do with photographers and waving to everybody, we come out of the crew quarters and get into the Astrovan, which is going to take us to the launch pad. And at this point, things generally are a lot quieter. There's no question there is a certain risk that you're taking when you climb and strap yourself on top of a rocket. And everybody has to deal with this in their own way. For me, my personality is such that I'm pretty confident that we've had so much training in how to handle problems that might occur during the launch that if anything happens that we can actually do something about, I have full confidence that we can do the right thing and solve the problems. Of course, there's many things that can happen during a launch which you can't do anything about. My attitude towards this has always been, well, if I can't do anything about it, what's the point wasting time worrying about it? And so somehow I have the right personality to be able to just take all those potential risks, put them to the side, and basically enjoy what's going to be a pretty fantastic experience. I remember going out to the launch pad before my first flight and realizing, you know, this is not the time you want to be thinking about, do I really want to do this? You get out to the launch pad, and the last time you were here was about a month before when we did a dress rehearsal countdown. But back then, there were hundreds of people crawling around the launch pad getting everything ready to go. Now the big difference is the pad is empty. There's nobody on the pad itself. We get access, we go up an elevator and then go through this little access platform here into what we call the white room, which hooks up to the door of the shuttle, the hatch. You can see the hatch in the background here. And the only people on the entire launch platform, other than the crew, is about a half a dozen technicians who help us with the final getting dressed in our launch equipment, and then they help us strap into the seats and basically close up the hatch, and then they're out of there. And nobody is closer than a couple of miles away from the launch pad. And so after the strap in, there we are sitting all by ourselves, just a few people sitting up in the cockpit of the space shuttle as the countdown is progressing. And it gets progressively more exciting as you get into that last few minutes, and gradually the vehicle starts coming alive.
T-minus 2 minutes and counting.
A couple of minutes before launch, you test all the hydraulic systems. You wiggle the engine bells around, and you can feel the shuttle is actually shaking when that happens. Then as you get down into the last few seconds, they have to actually open up these big valves, a big 17-inch valve in a huge pipe to let all of the liquid hydrogen and the liquid oxygen go into the engines, and you can feel this rumbling underneath you. And then 6 seconds before liftoff, the main engines actually ignite. You can turn off liquid engines, and we want to be sure that all 3 of our liquid engines are operating properly before we light the solids, because remember, once you light a solid, you can't turn it off. You're going somewhere, and you'd like to go with 3 good main engines. If there's something wrong with the main engines, and this has happened 4 times in the history of the shuttle program, they'll shut down on the pad and not light the solids. That's good for safety. You feel this rumbling as the main engines light.
4, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis as Columbus sets sail on a voyage of science to the space station.
The vibration which you feel at launch increases even more about a minute into flight when going straight up, you break the sound barrier. Here you can see the shock waves coming off the shuttle and the tanks and the boosters. I was amazed by how much the vibration increased as we went through Mach 1. This was the period of maximum dynamic pressure when the whole stack is under the greatest stress, and we actually throttle down our engines to reduce the structural stress at this time, but it still is shaking like crazy. Then there's a big flash. You're completely surrounded by fire for about 5 seconds. It's very, very dramatic. And the solid boosters, which now have used up all their propellant, they have separation rockets to push them away from the rest of the shuttle so they don't recontact.
Confirms good solid rocket booster separation, good staging.
And then, this is a picture that it was actually taken from a camera in one of those solid boosters. Now we're just running on our 3 liquid main engines being fed from the external fuel tank. Already the boosters have pushed us about 20 nautical miles, that's about 40 kilometers above the surface of the Earth. And you can see already we're in space. The sky around us is black. And one of the first things I noticed was the black of space was the blackest black that I had ever seen. At this point, the hydrogen-oxygen liquid engines of the shuttle give you a pretty smooth ride for the next 6.5 minutes or so, and what you're basically doing is now just accelerating so that you get up to orbital velocity, which is just a little under 8 kilometers a second. And when that happens, all of a sudden it gets very quiet inside. You feel yourself floating up out of your seat against the straps, because now you're in orbit, you're weightless. Then all of a sudden there's this big bang, 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 because we have to actually blow the explosive bolts on these attachment points, which is what we're holding the shuttle onto the external fuel tank. The tank is no longer needed. It's the one part of the shuttle system that fell back to Earth, burned up, and was not reused. Now we're in space, and of course to fly away from this we have to fire the thrusters of the shuttle, which are really quite powerful, and it's this bang, bang. It sort of feels like mortar shells going on around you. And then we turn those off. We're away from the tank, and I find myself floating out of my seat, float over to the window, and look out, and there we are coming up on the coast of Africa. And from space, the whole perspective is different. You look out the window of an airplane and you can see entire cities spread out beneath you. From an orbiting spacecraft, you can see whole continents. I hope you recognize here the Straits of Gibraltar. Here's Africa, and here's Europe, and the entire Mediterranean Sea spread out below you. Also notice one of the other things that's critical about the different perspective in space. We flew up through the atmosphere, all that vibration, dynamic pressure, but look at this very thin blue line. That's all you see of the atmosphere when you're in space. You can go out on a nice sunny day and look up at, we call it the big blue sky. I mean, it's almost a cliche in our language, but seen from space, you realize how thin the protective layer is that separates us from the vacuum of space. It's a finite resource. You can't keep putting stuff forever into our atmosphere and expect that it's not going to make any changes. So the last thing I want to describe about the experience of going into space is we used all that rocket power to accelerate us to orbital velocity. We're going really fast now, about 8 kilometers a second. Do you have any sense of speed? People often ask me that. Well, the problem is, what gives us a sense of speed? Well, you can look out a car window and see trees going by or billboards. Well, we don't have trees and billboards up in orbit. You can hear the wind noise, you can feel vibration, road noise, none of that. The spacecraft in orbit doesn't need to keep firing its engines. It just keeps going around and around. We're going really fast. There's none of the normal indicators of speed, though, so the only way that you really know how fast you're going is you can look down at the ground, and here I hope you recognize San Francisco Bay. There's the Golden Gate Bridge. So you fly over San Francisco, and 10 minutes later you find yourself flying over Cape Cod. That's 3,000 miles away in 10 minutes. That's not too shabby. And that's how you know you're going fast, but that's really the only sense you have of speed. Well, that's just one of the many parts of the experience of being in space. I hope I've given you a little sense of what goes on personally riding a shuttle up into orbit. At those speeds, of course, the views are breathtaking, not just looking down at the continents of the Earth, but looking at 16 sunrises and sunsets every 24-hour day. And then, of course, you're in orbit and you get set to go about your work.
Jeff Hoffman and Story Musgrave.
And in another future lecture, I'll be talking to you about some of the things that we do when we're in space, and also some of the interesting things that happen to the human body. But for now, I hope I've given you a sense of a little bit what the personal experience is of actually riding a rocket up into space. And that concludes this set of lectures on rocket science.